So let me quickly close this, put this here, close this, and quickly go to this here. So let me check if somebody join on this one. So far, nobody joined. Let me check the voice quality because I don't want the people think that I joined here without any. Hello. So let me check somebody joined. Yep, that's good. That's good. So right now, today we are covering. I think I don't need to do that much. Okay. I can simply do the post, copy from here, copy from here, and then simply write here. Okay, so this is the one, and I just have to. I can't pen it out. That's not right thing. Okay, so simply go here. So do. Now this is the one. What I have to do now? Go a washing. Just a second. I'm back. Okay, so hi buddy. So if you guys are new, let me quickly tell about Code for Coin. This is a platform where we try to give the information in a very crisp and very meaningful way. Right now we are uploading. Actually, we are in a process of learn. So what I did, I just clear everything that I learned so far, and I'm relearning it as I'm like you guys, so that I have more in-depth knowledge, and I'm trying to deliver that after some time in the form of short videos where I will cover very specific topics that is very useful in terms of your development, in terms of uh, making you better expert in coding or SQL. And in the future, it will turn into SQL to Python, Python to DS to. So it's a long process. So right now, nobody's joining, but I'm still fine. I'm still good because I know somewhere I need to keep on going. So, so when you come to my channel that is Code for Coin, so you will see the videos. It's a very concise information. You can simply go and check that out. It will be really useful for you, but don't worry. In the future, I will create the video by myself that will be more elaborative, and someday we can also do live session. I'm doing the live session, but that way it's more of like interactive. Right now, it's learning based. So, yep, that's it. So once you could come to Code for Coin, you make sure that you subscribe. Because this is my other idea. I'm not subscribing because I want to make it more genuine and make sure people are connected to my YouTube channel solely based on the content, not based on the fake, you can say, they just want to join, they join it. No, I want a pure breed of data engineers or data or the computer science students or computer science professionals so that they get the maximum value out of it. Okay, so that's why I'm not even using my other IDs. I'm not even subscribing through my own ID. I'm not even asking my friends with whom I worked for the last 5 years to subscribe this one. Okay, so yep, I want it to grow organically. I know it's gonna be tough, but not impossible. So here, when we go to the link that I provided in the description, they are majorly four links, but the one that you need to concern yourself with is LinkedIn. You can simply go and subscribe because I keep on uploading a lot of other resources that I don't upload here in the form of videos. For example, I write articles, I write what I learn in a day. So please, what I learn in a day is very specific. A lot of people might not know it. It will be really useful for you guys. So I don't want to waste more time. The one you need to be more curious about is the GitHub. In the GitHub, go to the repository, SQL repository, SQL repository. You need to go, and then you have to go to SQL 0 to here. Here, there's the roadmap. Don't miss. Just skip this one. Start with the chapter one onwards. Keep on updating. So here you have very case information related to the topic. There's some exercises, some notes. You can simply go through it before your interview something. So it will be very helpful for you in the future terms. So in the roadmap right now, SQL 0 to here. Error loading the page. Reload this page. Just wait a few minutes before you try again. In some cases, this may take an hour. Okay, so leave it. So you got the path, right? So you don't have to worry about anything else. Then the resource we are using as a reference to learn is PG SQL exercise because this is the official document for this application PostgreSQL. So we are just using directly from the official because it make more sense to learn through it rather than simply going somewhere and learning. Because this is official. Something goes wrong with your knowledge, that means you have something to back up, right? But if you learn from somewhere, you cannot argue with someone that I learned it from here. It's a legit no. It may or may not be. There's a question associated with that one. But if you are learning from here, that's what gonna happen is you have something to back up. You have some official website to back up that this is something I learned from here. And if something goes wrong, trust me, this is the point of reference. We need to talk here. So today, as you have seen the thumbnail, we're gonna do one is a recap of table manipulation, then we're gonna deep dive into data manipulation, and then your data type. So let's quickly delve into it. So as far as you know, let me open my notebook because this is really important and I love this doing this. So writing is one of the things that I love because my writing is pathetic and I love people saying so let me quickly write. Today is day number 12, and we're gonna mainly focus on data manipulation and uh, what else we gonna do it? What else? What else? What else? What else? What else? Data manipulation and data type, dude. You're not even replying. Yeah. Okay. So we're gonna do this too, but before that, we're gonna simply have a recap from yesterday about table manipulation. So why table manipulation become an essential part of DDL, data definition language? So table manipulation become really important at times because sometime when you create table, so what happened this cabinet, when you created a cabinet like this to store your data in this cabinets, you realize that this is something you formed based on the business rule that was provided initially. Okay, so you created this one, you fetched the data, everything looked, you tested, you productionize, client was happy, he gave you go to go, okay, you can go, we are done, they paid everything good. But after a month, they realized that this basic was done and they want to build more feature. For that one, they want to have a process data, they want to have more data stored within these cabinets, so they want to create more cabinets here that stores some information that is essential, that's quite essential or they are essential for the other feature to be embedded into their application. So you simply can't simply go and create a new database, then new schema, and then new cabinet inside those schema, right? You cannot do that one and then put everything here and then do start doing it because it's gonna incur infrastructure costs. It's gonna incur these things. People won't tell you and talk about this one, but as a IT professional, you should know about this one that it incur human resource cost. So every person that work in the project, they are billed hourly. So suppose my billing hour was 120 dollar per hour. So if we increase this one, so to build this system itself, you need to put more money into the infrastructure. When the people gonna work on this one gonna get more money, then you need a specific timeline. So there is a expenditure of timeline as well because time is money in IT, trust me. So instead of doing all this thing, SQL come up with a very clever strategy that why don't we create commands that will enable relational database management system to simply modify our structure or these cabinets. And this lay the foundation of data definition language of table manipulation. Okay, so there are that I learned so far is like two ways of manipulating data. Simply you can do two things in a table. What you have two things you can control. One is structure and second one is the data, right? One you can provide or you can play modify the table structure, and second you can modify the data. Okay, so structure is like add column, drop column. Okay, add constraint, drop constraint. Okay, here you can play with you can add constraint like not null, drop constraint like not null, or set default, drop default, and what else you can do? Let me check. I remember yesterday, but I forget. So add column, drop column, okay. Add constraint, drop constraint, add not null, drop not null, add change default. Okay, so simply add default, not change. Is it provided? Add default, drop default. Yeah, data type. When you did this thing, then you can simply do is change data type. Now change name of column and then change name of table. So 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3. So the very basic thing of basics, DDL or table manipulation, you can do the 9 thing. Play with the columns, adding and dropping. Okay. Then if you can add the column and drop the column, then you can also make them not null and uh, drop not null. But then you can also do the set default or drop default, and then you can rename the column and change the data type. Then you rename the column. Once that is done, you can add constraint to that one, or simply you can simply change the table name. So this is what we usually do, and for how the structure is very simple. It go with a combo of two. You see alter table because you are manipulating the data or table manipulation, right? Alter table is by default there. Then the table name, the schema dot table name, and then it become really easy. For example, when we add a drop the column, simply add column, and you are simply adding the column. So it's same as you need to provide what you were using the structure or the syntax in your create table name and uh, this one data type. I think you can also provide default value here, not null, whatever you feel like, instead of like doing it later. In case you forget and you need to do it later, we will have that structure as well as part of this, and then simply drop column name. So this is done. Add constraint, simply this one, add constraint, drop constraint, and you put the constraint. That default simply alter table. Right now, these two were simply on the column level and constraint level, so that's not a big deal. But not null, null, okay, adding and dropping, then adding your default value and dropping default value. These are the entity level or the detail level, the information level, right? So it's a data level. So that's why you change it at the alter column. So you change at the column level. So you first alter the table, then you alter the column for adding and dropping not null and adding and dropping your default values. Okay. So default value not null comes under the alter column. And then if you want to change the data type, again alter column is data level. So alter column, then the column name and type whatever the type is. And if the type you're changing it not explicit, it's implicit. Uh, it's implicit. It's explicit, right? So you have to define some rules like when you convert a string to integer, there's possibility that the string text might have a white space. The string might have something that cannot be converted into integer like underscore or something. So you need to specify what kind of uh, pattern you want to find in the text and then you want to convert into integer. That's become necessary to use using. So when you do explicit type conversion, you need to give the expression how want you convert. So that's something you can use it using keyword rename. Simply rename column from this to this, and again when you want to rename the table, just rename. You use the column name, right? You don't have to do it because already is here. Then to rename to the new table name. I'm sorry. So that's it all. Do you have any doubts? If somebody joined, let me quickly ask this to the people. Okay, so nobody joined. I'm the only one who sent the message, so leave it. Okay. What now we have to start is data manipulation as really important because we are very limited with the time. So and we need to learn a lot. It's not gonna be gonna rush it out because we need to learn it properly. So let's get started. Data manipulation, data series. How should I do that? Data manipulation. Hmm. Okay. In the multiple role in a single incident products. This value. So incident products default. You can also request default values explicitly for individual columns or for the entire row. Oh, so guys, now this is done. Today we're gonna start with data manipulation. So I will just do this data manipulation. And the first thing we're gonna do in data manipulation is insert, right? We're gonna learn about the insert. So if you can see my screen, insert data, when a table is created, contain no data, the first thing you do before a database can be much used to insert data, data is inserted one row at a time. Okay, so data insert one row at a time. You can also insert more than one row in a single command, but it is not possible to insert something that is not a complete row. Okay, so you can simply do a stream insertion or you can do a batch insertion and then commit it. So what happened? So every time one data is inserted, I think it use a commit that way, make it permanent, then do it again and again. Or simply you insert everything when you are satisfied that everything is looking good, then you do a commit. So that's like a batch, like you make sure that everything is live all together. And in the first one stream is like whatever the data is going, like one record, then it's available again immediately. Second goes, it is available immediately. So it's a stream and batch. So we're gonna use create table to create the table we already created that we're gonna leverage is that's a university and then student detail. And what we're gonna do, we're gonna perform different ways of insertion to understand how the things goes. First one is simply insert into table name values. Values is the keyword that use the value or the entity information here and insert it directly into the columns. Okay, the data value are listed in the order in which the column appear in the table. So make sure when you are using this one, what's gonna happen? This should be follow two things. First one is it should be in the same order as the column in your table you have defined because the column order and the column number is a static in a SQL database once you created it. So now this gonna get inserted into this one. For that one, the order and the data type should match with the table structure. In case you don't want to insert all the data, for example, out of this three, you want to insert only for two, for example, product ID and name. Like you don't want to put the price at the moment, okay? And you also know that for any of the column, the default value is null, that is emptiness or nothing or unknown, right? So you can simply write here now the columns. So if you're not providing this brackets with the column names, by default it assumes that all the columns will be there. So that's the benefit of using relation database management system because at the back end it take care of everything. So now from here, you can simply remove the column that you don't want to use. Okay. And here you don't have to put any order because you know this mapping one to one. So product ID, you get it here, right? It's the same order as your column, your table, but now here you can play with it. You can put the name first, then price. Automatically it will. So here is just like to get the mapping for the name. Name is cheese for a price is 9.99 and the product ID is 1. Automatically it will insert in the same order of table structure. We just here to make sure whatever the data I am giving for an entity, it's in an order, it has a mapping to which column it will. Okay, that's why this is needed. And as I told you that if I don't want to add something like price here, so it will automatically take the default value of the price. Right now I haven't added any default value, so it's gonna take unknown. Suppose I don't want to put it unknown, I want to put it 0, you can put it here, the value like default 0. So that's the keyword we're gonna use to put the default value for a column. So now this is the one, this is this default value. So at times you also want to put the default value for all the columns. So you cannot simply write all the column name and then you put values and then start writing default. That doesn't make sense. That means there should be something for this specific case, right? And we indeed have this one. Insert into products default values. So what happened? It will tell the RDMS that take the default columns and then put default values into it. Simple. Okay, I think that's it. Let's quickly practice this one into our PostgreSQL, right? So we have these two data. We're gonna insert more data into it, okay? And you see the ID is a primary key, but as I remember, we were using generate, so it will automatically generate it. We don't need to do anything. We just need to make sure. So now I will you insert into. I need to go to the schema, right? Flow student. And this floor, I need to go to the specific cabinet of a student start detail. Now I want to add the value in particular column series or column in the rows for a particular entity. Okay, so that's my plan. So one thing I understood right now, if I don't provide here in between the table name and the values, the column I want to put, so I need to make sure I put the values in the same order of this one. Okay, ID is a primary key that auto generate. But since I'm not giving the names of the column here, I need to put it a value. So what it's gonna take, it's gonna default value. So it will automatically, whatever the generate function will generate, it will automatically insert it here. I don't need to bother with the name. Okay. Second one is the name. Right now I'm putting Reva. Okay. Third thing, I'm going to put the age is 19 and I'm putting default. Okay, for university ID. So if I select this, okay, so see, this came here. Okay, but now in a second insert, I can see, I can simply write one more insert here. Let's write one more insert here. Right? Now I'm putting gray, and gray is 25 years young man, default. I'm putting default, right? But now I don't want to put this and this one because I'm writing it very often, and sometimes it happens that for every record this has to be default. So it look very awkward. It look very time consuming. You need to write type default for long. No, I don't want it, right? What I want, I just want to give this to value, and whatever the column I'm not giving, I want to take it by default. So here you can do it, define the columns. So I'm going to give the name and the age. And the remaining column I'm not defining on this one, it will automatically put the value default. Okay, so it's 4 and null came in, and I don't have to worry. Because the problem is integer is check constraint is there. Okay, so I'm not putting it not null, right? Am I putting it? I need to check once again. Constraint add not null. Okay, so I'm not putting it. Okay. So now you see it here, right? This one. So now I will like, why should I put the name first and why I need to put the age second? I don't want that. What I want to put the age first, and then I want to put the name. Age is suppose 20 years old, and she is Nikki, right? I don't want this one. Right? So you can play it. You can simply remove this one and you put age here, comma name. So what happen? It will automatically map the age of this one with this one, and Nikki is with the name. And when it will try to insert, it will automatically based on the table structure. So you don't have to worry about anything. If I run it again, it should properly give me the result. 5 is the ID, auto-generated. Nikki was the name I gave it secondary, not the first, because now I have changed the mapping. So it's like mapping here, then age and then null. Good. Now you see it. I can remove this one. Just it's just a fun language. Now you see it. What happens here that I am trying to put the value again and again, like more insertion. So based on this one, what happened? They decided like, if since we already know we're gonna insert it as an individual, why don't we put one comma to segregate the columns and simply write the column here, the entity, and entities here, Reba 19 and this one, and we can simply remove it. So insert into student and student detail, name, age, gray is the name, then Reba 19 and this one. See, again the same thing came, right? So now what happened? We are providing multiple entity information in the same insertion. That's the beauty. And we did that, okay? So we pretty much cover everything here. One thing that I want to cover and I didn't cover it directly there is to make you understand the importance of this one. So right now, this one, if you can see my screen, right? I quickly check if somebody joined, if I have a question. No. Okay. So it is also possible to insert the result of a query which might not be a row or one row or many row into your table. That means you can insert the data in a table from another table, or when you merge and create a data set or the result of a data set into a table. Simply you have to do is like insert into product, and then again you have to define the columns. If not, you need to make sure that it's the same as the bracket concept. This act as a bracket concept. If you're not putting it here, we need to put it here. I need to check. I will check. And directly you can use this select statement to get the value. Right now I don't have, I have it. Okay, so I will show you beauty of this one. Okay, so this is the one insert. So right now I'm using the same table, student detail. So I'm trying to replicate the data. I'm trying to duplicate the data. Sometimes you need to do it, okay, for testing. Like now I'm doing insert into dispute then dot stud underscore detail, and I want a name and age. Now I'm going to directly use this table select name and age from stud student dot stud dot detail. So what it does is it will take and run this statement select, and this one if I run it, okay, so see it give me this result, right? It is giving me a result of name and age, right? Now this is a result set, it's not my table result. I got the result. I select what it does, it goes and read one record at a time and scan all the data table and give the record based on the selected state. Now I can now this data set I can insert into this table. How? Insert into the table name, then the table columns I want to put, and simply execute. So now you see 8 record, and Nitin is repeating twice. Your Robert is repeating twice. Gray Rabba, they are repeating twice. Because what I take the I run the SQL statement, get the data, and then I reinsert in the table using this format. But one thing I need to make sure, I need to check whether null age and I'm saying that can I not mention the column and will automatically take how it was taking in the insert query one, or it will fail. It indeed fail. Okay, error cannot insert a non-default value into ID. Non-default value. So, or because the problem is if I write default, will it execute? No, no, no. Default is not allowed in this context. Yes, it does make sense. Okay, what should I do? I thought like if because if I put because problem is here cannot insert a non-default value into it. Non-default. So it indeed take null as a value that I'm trying to insert, not null as like the null that like. So I'm trying to use override method, and I don't want to use this one. So that means I cannot use it. Now the problem is like the the mapping will get messed up. Can I not? Problem is I don't have the identity. Uh, I cannot do it. So simply you simply put it timing because of the entity I cannot put it. Simply insert into table name and then the column names and then select whatever the statement is. It should be name, age, and then uni ID. So if I run it, it will show me proper results. Yep. So this one is really interesting. The scenario I told you, right? This one. Moving from this to this, you can simply do it in the same manner as like insert into table B. This is okay, okay. And the column, then select column in the same sequence as you define it here from A, whatever the condition is. And voila, within like minutes, the copy paste is done. So this is what I call usually copy paste in PostgreSQL. So insertion is done. I think we can simply move to when inserting a lot of data at the same time. Consider using copy command. It is not as flexible as insert command, but it's more efficient. Yes, I was talking about this one, copy command. I use this one. So if there is a lot of data, the problem with insert of this one is it will read one by one and then try to copy that data into this Postgres table. But Postgres table is nothing but a file system, right? So it stores the data in the file. So why not directly create a copy of the file of this table and insert it directly into the table where I want to insert it. So it's not as flexible, you cannot make a lot of changes, but it is much faster when you need to create a replica of the same table. And at times it needed. So we will see that in the future. Update. So what happened with the update is you update a value in the value of a detail of an entity, or you update the detail of an entity is called updation. So simply the structure is update, then the table name, and the keyword that is you need to remember at a given point of time is set, and the price equals to 10, where is the condition. So what happen if you don't put the where, what will happen, update is the same as select, it will go and read each and every record. And if you don't put the where clause, I will tell you what is where is, it will start putting the value of the column or attribute or the detailed price of the entity to 10. But if you put the where clause, where is like filtering out. If a record with the false statement, it will drop. If it gives the false statement, it will drop. For example, it goes product to one. Check the price is 5 or not for the product, for the number one, record number one. Okay, the for entity number one. It was 6, so it will drop. Okay, I don't need to do with you anything. Then it will take second, third, fourth, fifth. On the sixth one, you check the price, it was 4. It's not matching. That means condition is false. You will drop it. Okay, but the eighth entity have the price equals to 5. That means it's returned true. Where clause satisfied, it will go into 10. It will go into that entity and put the price as 10, and then put that thing back into your table. Now the entity 8, which was initially before running this query, have the price 5, now got updated to 10. And none of the other the entity got any kind of updation or modification. That's why this where clause is really, really important. Okay, update table set this one. And you can update more than one column in an update statement by using listing, by command by listing more than one select set clause. So this is the one statement. Was the one updation, but you can do the multiple attribute or the detail of the entity updation in a single one when everything is following the same condition, right? If A is greater than 0, whosoever the entity has, whosoever the entity whose detail A or the attribute A, characteristic A, or column A value is greater than 0, for that one, for that entity, make A 5, B 3, and C 1. That, and this is beautiful, nothing much. But now the question is the same question that I want to ask every time. Here, like same as the check statement, does it work in the negative one? That means if the price is null, will update or it will bypass. Like it has to be false, it has to be true only for updation to work. But it's same as the check statement that it has to be false, then only it will drop. We need to check. If say it's same as check where the check is statement. In the check statement, what happened? Data will or the entity that is coming to insert and it check the condition. If it gives the false, only false, then only it raise error. Else it will bypass or it will allow it. It will fail. It will let it through. So that means for a condition that gives the value true or null, both are applicable. In this one, where it is dropping and filtering out the value that you want to update, will it take only true when the expression is true? Then only it will take the value to update, or the entity, it will take the entity to update its detail, or if it is a null, it will allow it. And that's something I want to check. And that's more interesting than anything, right? So let's quickly go to second update. So I will update your student, and I want to access the start detail cabinet set uni ID. But is uni ID unique if that's the case, then it's gonna pop up uni ID. H constraint Okay. Uh, age default values. Add column. Okay. So there is no constraint in this one, and default value is null, and I see that, so that's fine. Because the problem with the unique is unique allow two things. First, the value of the entity should not be repetitive. Okay. That means when it's compared with other values, it should not return the value true. It should not return the value true. But if it's null, unknown, that means it bypass the things, right? Yeah. So in null, in a unique columns or combination of columns, it can hold two values. First is a distinct value or null. Okay, so that means multiple columns can have, or multiple entities can have null as a unique value, and that's why the primary key is like only unique value. That's not name. Okay, so I will update this one. So my take was that I need to update university ID to say two, but condition was where only for the university whose ID was initially one. So technically, it should not update anything because I can't find any of the entity which has university ID one because of null is unknown. But will it work like check statement? No, no. That's the beauty. That's the beauty. In the check statement, it allow true or null, but in update, it has to be true. It has to be true to update. It won't update for unknown values. Okay, so that's the beauty. So in updation, if the condition is returning true and true only, then only it will update. It won't update for null or unknown. That's the beauty. Now I will change it to is null. Okay. So it will check all the record. If university ID is null, it will put the value as zero. That means not defined. That I was initially talking about that I want to convert it this way. See, all the university IDs now turned to zero. Beauty, 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 beauty. Okay. So this is a combo keyword is null. Check whether the value for that detail of an entity is null or not. If it's null, it will return true. That means it satisfy the where clause. That means for that particular entity, the detail university ID, I can put it or update it to zero. Done. Any question on this one? No. Okay. And you remember that I told you that in this one you can update multiple things. So simply you can also write age as 18. I'm making everyone young. I feel like I make everyone young. Okay. 18. No, I will make 18, right? See, I made everyone young. How about I make them a bit more younger, 16? Do you think it will pass or not? If you're thinking it'll pass, no, it won't. Because the table structure told them there is a constraint, there is a rule that age should be greater than 18 years old. So it should violate the check condition. And this is the beauty of Postgres or the SQL that it tried to mimic what happened in the real world. So I don't want to do it. Okay. So I will keep doing this. My all records are back and this one. So this is also done. I have created update statement and now I was thinking to reverse engineer this one. Why don't I put equals to null when id is 0? Let's do it, dude. I want to make the data. Now it came back null. Done. So this is also done. Now deleting. Okay, now. So far we understood how we insert the data. Data is done by one. One done, commit one done, commit one done, commit. Then we understood the update statement that if I have to update everything, remove the where clause. If I have to execute and update a particular group of entities, Then I need to put the where clause. So for whatever entity the where clause return the true for that expression, updation happen for those entity only. Now deletion same way. If I have to delete all the record one by one by one with some condition, I will simply use the delete statement. Okay. If I have to delete everything, just remove the where clause. So how it was update, table name, set, condition, and where filter. Here, delete from. It will have one more keyword, delete from. I don't know why delete table name they directly use it, why they are using from. Okay, so see here. If you use delete from table name, it's gonna delete all the records. You can use delete command to remove. The syntax is very similar to update. So update was, as I told you, that update has update table name directly. I don't know why they kept it from. They should simply use delete table name because it will then synchronized with the update statement, and that make more sense to me rather than simply going ahead and creating a different one. But just remember that delete from table name where price equals to 10. Remember what it says, price equals to 10, right? So, so what is gonna do? It create all the record one by one, how the select and update does, one record at a time, and it will check if the price of that entity detail or the entity price is 10, then only it will delete one. If not, it will keep it there. So let's quickly check it how we do it. So third one was delete. Okay. So firstly, I'm going to run a delete from floor is a student dot and then the cabinet is stud and execute it. Now everything is deleted, but the thing is I don't want everything to delete, right? Why I want? Well, where I can view. So I want to check everything. So I can write uni ID is not null. Is there any record which has a proper value that is not unknown? It has the value. Answer is no. That means it won't delete anything. We'll get all the records back. Okay. Now I need to delete a specific case. That is, I want to delete all the people whose age age is suppose greater than 30 years old. I don't want them to keep it in the record. Okay. So how many record we have? Robert, right? Twice Robert we have. So two records will be gone. That means six records should be available at the moment. Yep, 60 is there and Robert is gone. Okay. That's how we delete it. Now let's quickly go to. So far we have explained how to add data to a table, how to change data. When what remain is to discuss how to remove data that is no longer needed. How to remove the data that is no longer needed. Just as adding data is only possible in a whole row, you can only remove entire row from a table. In the previous section, we explained that SQL does not provide a way to directly address individual rows. Therefore, removing row can be done by specific condition. Okay, they don't have the idea simply Google something like that. So you need to put the condition. I don't know why I have some. Okay. Therefore, removing rows can only be done by small condition. So in the previous section, we explained SQL does not provide to a way to directly address individual row. Okay, it doesn't provide. You have to do it manually, creating a primary key or something. But in any case, you can use a where clause to delete particular one. And the reason is very simple. Okay, why? If you feel like okay, I know I inserted record. Suppose you are initially working on the table. Okay, I will tell you. Let me show it. The biggest problem with a SQL database system is not problem, but the architecture is when you create a table, it fix the order of columns. Okay, so if you define it like column one as ID, column two is as name, and column three as a age. So in my table, it's gonna stay like this only. So if tomorrow you want to access this one, you can simply put the name or you can put 1, 2, 3 as well. Because one is always column one, two is always column two. But row is not saved in the same manner. Optimize it, they store the rows or individual in a different fashion. So if you have row number one, or basically entity one, entity came and it inserted into the memory, then entity two came inserted, it won't have the number one, it don't have the number index two, it can jumble, it can be stored first somewhere here two, and then it can be one. And because of this one, you cannot simply access the row with the row ID or something. That's why you have to create a primary key. If you have a primary key, that's fine. If you are creating primary key using generate or generated as always, okay, generated always or as always, as identity, generated always as identity, and you make it primary key so that nobody can override it. And even it does, it's always stay that primary key logic. Okay, so that why it become necessary, it become important for that. Any questions? Okay, there's no question. Okay. So you cannot access the role based on the insert sequence, but you can for the column because they are fixed. That's simple. Okay. So you don't know. Therefore, removing a row can only be done by specifying the condition that row to be removed have to match. If you have a primary key in the table, you can specify the exact row, but you can also remove the group of rows matching a condition, or you can remove all the rows from the table at once. This is the one. So we are done with three manipulation. That's very important. Root is for create, R for read, U for update, and D for delete. So we are doing that one, but read is not here. Now returning a data from the modification. Oh, that's good. Oh, that's select statement. So sometimes it is useful to obtain data from modified row when they are being manipulated. The insert, update, delete, and merge command all have an optional returning clause that support this. Use of returning avoid performing an extra database query to collect data and is especially valuable when it would otherwise be difficult to identify the modified row reliably. The allowed content to be returning clause as are the same as select command output list. It can contain column names of the command target table already expressed using a column A. The common shorthand is returning star, which select all column of the target table in order. In an insert, the default value available to returning is the row is as inserted. This is not so useful in a trivial insert since it would just repeat the data providing by the client, but it can be very handy when relying on a computer default values. For example, when using a serial column to provide a unique identifier, returning can return the ID assigned to a new column. Create table first name, second name, insert into this one last name, ID. Serial as a primary key. Now return clause is also okay, insert into returning. What does return does, dude? Is it like okay? I feel like the same like merging the select statement with the one. Like here, right? What happened here? I run the query, then I write the insert to retrieve the data every time. If I run a query, like I create a table, right? And then I was like, I insert the data. Now I want to see this data immediately. I need to write a select star from this one, but instead I will write this one. See? I knew it. And if I remove it and I run this one, oh, I need to drop the table. Drop table if exists, and what's the name uses. See, okay, so returning is not that great, but I think it's pretty fun though. This is something new I learned. So if I am manipulating a data and I need to see the manipulated data, so instead of writing a separate select statement, I simply append the select. So basically, I'm returning the this one. Okay, makes sense to me now. It does make sense. It's interesting, dude. I know that you can do this way in Postgres. So let me write this one. And it should not show me any result, right? Okay, so query returns successfully in 141 milliseconds. Because right now what I should have done that after this I need to write a select statement to see the update. But what happened? Where this one I need to see the data at the moment. I need to see that one, right? But what how is manipulated. So now rather than writing a select, I will simply attach a return the return or returning how much, but I need to return everything. So select star. Like how is was select star? It is returning star. So what it gave me, there is a difference here. It is not giving me the updated values. It is giving me that the records or the entity that get affected because of this one. It is affecting these two. And this is really interesting. This is the first time I love it. And I think I can do with this. Like, can I do this? See, it's also an statement, right? Returning star. Can I do this way? Okay, so I can't do it. So you cannot add returning to a select statement. So now see, my record is 6 in this table, right? But when I was running delete, when I did this one, it gave me the affected records, with the affected ones. And if I do this one, right, returning star again, I want every data that got affected because of this one. See here, I'm updating all these 8 records. This is so fun, dude. This is so fun. This is so fun. Returning, I was not aware of this one, dude, in Postgres. So cool. So I can do with anything. I do. We can do literally with anything. In a merge, the default value available to returning is the content of the source row plus the content of the insert update or delete target row. Since it is quite common for the source and target to have many same column specifying Returning star can lead to a lot of duplication column. So it is often more useful to qualify it as to return just the source or target. For example, merge into product using new product on this one. When not matched, then insert values this one. When matched, then update set equals to returning p. In each of this command, it is also possible to explicitly return the old and new content of the modified. Okay. In a merge, the default data available of to returning is the content of the source row or entity plus the content of the inserted update delete or this one. One second. Yep, I was. Yeah, that's true. What it says that in a merge, the default data available to returning is the content of the source entity plus the content of insert update or delete target row. Since it is quite common for the source and target to have many of the same column, specifying returning stack can lead to a lot of duplication column. So it is often more useful to qualify it to a return just the source or target row. Okay, just the source. Merge in product B using new product and and when match an insert value into when not match when match then it creates that name because stupid and name and price update product set price equals to price equals that where price is let's let me do it once more like how about okay, so I'm trying to update the name Nitin to Nitin Rawat. Okay, so let's do it. Update. Floor is a student, and then the cabinet is student detail. I need to set name as Nitin. No, I need to make it capitals. Okay, I want to make it capital. Where it will make every name this one. I need only the update when the condition is true. Where name is nothing. Okay, so it will check the case statement as well. So we have to record that will update to this one technically, right? So if I run it, yep, it does that. But right now I don't want to see this. So I want to see from here. And this is done. I want returning the start. So it will return the factor column. See? So the result of this one, what happened in this one. So it will take it, it will update, and this is the result of the one that I want. When I did delete 30 and 35, and what it got, it deleted this one. Okay, so the target of this delete statement was this two statement that got passed and it was deleted. So it gave me result of this query. And if I go here, if I run this one, it gave me a result of this two because it take this two value and then update it. Delete is like taking this out, right? Updating is like I update here. And then whatever it is. But the thing is, this is the target column. I need to make sure that I got the old column as well. Like not entirely old column, but can I write like this new dot this one star? Okay. Now can I make it old dot star and do this one? Yep, I got this one right. But this is not something I want. What I want, that name I changed. So I want the name as old name and new name as new name. See, now I can see the old one and the new one being updated together, right? That's the beauty. That's I love it. So okay, anything else on this one? So returning what it does, it give me the affected values of this statement, be it whatever it is. I can see what kind of a data it is affecting finally. Okay, and if I want to check the source and the target, what the changes are corresponding, I can use the keyword old and new to retrieve it in this way. So returning is really, really cool. I think I love it. This is done though. This is done. I need to come here, but not right now. I need to check for data manipulation. So data definition. Now that this is done, pretty much returning also don't delete. Okay, so I will check for data. Data type. Security creating a schema. Hmm? Data type here. So there's too many data type, but I think the one we're gonna look in the future, but right now I'm not going to much into detail. I'm going to use or study the one I feel like is important. So first is numeric. Obviously, we always need the numeric. It's important. So right now, you understood that when I create a table, anyone join if they have a question, I need to answer that. Nope, nobody joined. But let's quickly delve into data type. So I told you when we create when we install relational database management system, whenever we create a database, it automatically create a building, allot a space, and it create a building whose first floor or default floor, ground floor is public. This space and this building I'm creating is database. And the one who is managing this one, the operating manager is our relational database management system, right? This floor is nothing but your schema, and inside the schema, we create different cabinets. Like you have seen the cabinets in your houses, right? On the wall, how we create a cabinet where we place the things, right? So based on our requirement, we create that one. This cabinet is nothing but tables. Okay, cabinets. We understood this thing. Yes. Okay. I told you that data will be allowed to insert when it passes through the rules we have implemented on this three layers based on our requirement, based on the application we want to make with the outside the world. On the very first constraint or the rule that we have implemented is the data type. For the part of any cabinet, like say this is the cabinet. For a cabinet, you want to put a value here, have a data type that define what kind of object you can insert it. For example, you like here I can place only the glass item. It should be glass. Here I can like gold item. Here silver item. Okay. You cannot simply come here and put the gold item. It has to be silver. It has to be gold here. It has to be platinum. It had to be glass. Okay. So this the nature of the data that can it is stored in this storage is nothing but the data type. So this is the very first constraint we put on a data that we are storing data type. So what kind of a data we usually deal with? First one is integer. Second one is a text that we have seen so far, right? Third one was serial, automatically created, right? And then in the text we have character, then varchar, then nvarchar, and for integer then it should have a float, and then date, then time. There is always a range something, but we are not getting into right now. Okay. As we created the project on the PostgreSQL, then we will create multiple scenarios. We will search what can be more efficient way of storing this data. So for numeric, we have integer, then arbitrary precision number, then floating, and then serial type. This three. Okay, small int and integer. Integer is 4 byte character. It can take this much value. So if you know the value the user gonna insert in range between this one, you can put it. If you know the value it can store is between 32K plus minus, you can simply use a small int. Okay, but it is optimized. You don't have to worry much. But you should know when decimal is like it will take up to this many digit from the decimal point and up to this many digit after decimal point. I think this is more than enough. When numeric user specified precision exact, it can take the same number of this one and this one and this one. So what is the difference between decimal and numeric? I think decimal round off, numeric doesn't. Both are variable, right? A variable precision in exact six decimal. Okay, so it take up to six decimal. If you get the seven decimal value, it will automatically round to this one. Double precision is just the double precision of the real 8-bit. A small series. Okay, we have a small series. So how we have serial, right? So serial, it take 4 byte. If you want to take a lesser to this one, you take a small serial. And if you want to take bigger, like you know that the number can goes to so big, so can use big serial. But what is a this numeric and what is the difference between decimal and numeric in SQL? PostgreSQL. Numeric requires the database to store the floating point number exactly as specified. With this exact precision and scale, decimal is required to store the floating point with precision, at least as requested, but with a scale equal to 1 than request. Okay. There's a notable difference between numeric and decimal in the standard. The numeric data type is a strict, it enforces exact precision and scale that you have to specify, and the stark contrast to this one, which allow more number than the stated precision. Then it literally round off this one. The decimal and numeric are numeric data type that have fixed precision. So decimal and numeric are similar. Now, let me ask the cloud. That's why that's the best thing about the AI right now is you don't have to go to search all the website. You can simply go to one place and get this answers, right? I don't know what happened. I can simply copy paste this one. Okay, same thing, identical, just an alias. Just an alias. Postgres internally treat both as numeric. You can either use it behave completely identical. What does numeric precision scale mean? Then precision total number of digit allowed, total number of digit after decimal allowed. So precision is before the dot and scale is after the decimal. Numeric can store something like this, 8 digit and after 2 digits, the total is 10 digits. Total number of digit allowed 10. Precision is total number of digit allowed and total number of digit after the decimal is allowed. Good. 8 digit before and after 2 after equals to total. Then unlimited precision, so it can have up to 13,172, 10 digit allowed and 0 decimal. 10 digit total and 2 after decimal. So that means 8 on the left side and 2 on the right side. That's total. Variable. Float and real. 4 byte approx fast and money and text. Integer this one. The key thing about numeric is that it exact. Unlike float, which can have round up. Okay. In Postgres, decimal and numeric are exactly the same thing. They are alias for each other. Okay. Got it. So what I learned is PostgreSQL, numeric and decimal both are same, okay? And it has the one is keyword that is numeric or decimal, this one, and you write 10 and 2. It says total digits. It says digits after decimal. Okay, so I say for example, I write numeric, I can take only total four numbers or digit, out of which two can be after decimal. So 2 1.4. See, total number of digit is 4. 1, 2, 3, 4. And how many is allowed after decimal is 2. So that's the thing that decimal and numeric is being used is because it stores the value exactly. But for float and double float is like they have the number of digit allowed after this one. They can simply put some zero and some random value. So it's approximate. But for money and finances, you need the exact money till dot. That's why for money like dollar or something, you need to use numeric or decimal, not float or something. But I need to ask you then where to use float. So where to use float and where to numeric. Numeric is very clear when we have a decimal value and we need to store exact value. So numeric is like money, tax, legal, and measurement. It has to be very final. Float when speed matter more than the precision. Okay, longitude and altitude. You are doing million of calculation in a tiny round of error is acceptable. Okay. S- Speed is slower. Okay. Because numeric store very precise value, so it take more time for operation, and it's variable. You can store much. Is fixed. Float is 8. The classic mistake is storing money as float. Obviously, it gonna round off, so it can create issues. Makes sense. So I think numeric is pretty much done. You can simply use this for this integer is byte over 4 byte. You can use it. Then small int, then big int. Then decimal numeric both are same, so you don't have to worry. Then okay, so in Postgres, it's not float that people use, it's real that people use. It's for six decimal digit precision. Okay, and double precision is 8 byte. They don't have 2 byte. Doesn't make sense. Then real serial is like small serial and big serial 248. So in Postgres we have so in PostgreSQL we have real instead of float. I think that's actually Postgres has both real and float. Okay, 4 byte. Oh, 4 8 16 32. Because it accept only 6 digits after the decimal 3 6 and only 6 digits. 3 4 5 6 and for precision is 4 points. So it has float 4 and float 8 because 8 byte character it can take. 4 and 8 double is float, 8 is 8 byte, and float 4 is real 4 byte. 6 decimal digits, 15 decimal digits. After that, it has started rounding off 6 decimal digits. 1, 2, 3, 4, 5, 6, and the seventh one will become round off. See, 7 become 8. And then full precision is like 15, then 16 become round off. 1, 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, got it. Got it. And real is 4 byte precision, and double precision is like float 8. Makes sense. And float 1 to 24 become 4 byte. 25 to 53 become this one, and by default become double precision like 16 byte. 4, 8 double precision. Ah, got it. When you need to save storage at a less precision. So it allows 6 and how many digits? 6 and 15, 6 and 15. 6 and 15, 6 and 15, 6 and 15. And this is really, really interesting too. Yeah, this is really interesting. So that means let's do it here. Select 1.1, 1, 2, 3, 4, 5, 6, 7. And I want to convert it to real. That is precision to 4 byte. 7 because 8. Yep, it does change it. 7, 8, 9, 10 become 10, 1, 2, 10, 10, 11, 12, 13, 14, 15, 16, 17. So 15, so it should be is double precision. Or how it should be written is load double precision. Double precision. 7, 4, 5. See, 16 becomes 17. So real is nothing. No, I can keep it in the same. Real. Now see here. If I run this one, see, 6 and the 7 become 8. Here, 16 becomes 17. So real can store values exactly till 6 digits after decimal and round 7th. Here, exact 15 after decimal and round 16th digit. And the interesting part here is that I feel like you should know I can do the same thing using float for 4 byte character that is nothing but real, and here I can also do it float with 8 byte of character that is nothing but precision. Here, so what it does is SQL syntax error here. Let me remove this one first time. Let's check if it does run. Dude, what's happening? Ah, dude. When you're dumb enough to do dumb things. You put the comma here, but I forget this is a comment. So you need to put a comma here. But I think better to be safer side, put comma here. Put a comma here. Put a space. Put a space. Okay. Now I can remove this one, this comma, this comma. See here. Float 8, float 4. See, real and float 4 are the same, right? Float 8 and double precision is same. So I should remember that real is nothing but float 4 and double precision is nothing but float 8. But now question is, does at given point of time there is 16 as well? It doesn't exist. This is an interesting one that I learned today, apart from returning. Ooh, this is really something new. No, integer is done. Arbitrary precision is done. Is precision that numeric I was talking about. It can have an scale. Infinity. Okay. So this is numeric type, then integer. Okay, so now integer, small int, integer, and big int. Same. These three things that I was talking about. Done. Numeric, we already talked about. This is also done. Nothing much to do. Numeric values are physically stored without any extra leading or trailing zeros. Thus, the declared precision and scale of a column are maximum, not fixed allocation. Okay. In this sense, numeric type is more often like varchar n than character n. The actual storage requires is 2 byte of for each group, a 4 decimal digit plus 3 to the 8 byte overhead. In additional ordinary numeric values, the numeric type has several special values. Okay, so the numeric can store numbers with a large number of digits. It can recommend it for storing monetary amount or other quantity where the exactness is required. Calculation with numeric values yield exact value where possible. Addition, subtraction, multiplication. However, calculation on numeric values are very slow compared to the integer type. So, to the floating point type described in the next section, we use the following term below. The precision numeric is the total count significant digit, the whole number, and this is the number digit to the total both side decimal. The scale of numeric is the count of decimal digit in the fraction to the right side of the decimal point. So the number has a precision of 6, 2, and 4, and 4, 6, and a scale of 4. Okay. Positive with a scale may be positive or negative still alternatively. Okay. Scale is zero. Numeric. Without any precision on a scale, unconstrained numeric column in which numeric value of any length can be stored up to implementation limit. Column of this kind will not cause input value to any particular scale, whereas numeric column with declared scale will cause input value to that scale. The SQL standard requires a default scale of 0, that is correlation to integer precision. We find this bit useless if the concern about the portability always specify the precision and the scale. The maximum precision that can be explicitly specified in a numeric type declaration is 1000, and unconstrained numeric is a subject to the limit of the described point. If a scale, if the scale of a value to be stored is greater than the declared scale of the column, the system will, if if a scale of a value to be stored is greater than the declared scale of the column, the system will round the value to the specific number of fractional digits. Then, if number of digits to the left decimal point exceed the declaration point precision minus the declared scale, an error is raised. For example, the column declared as 3231 will round the value to 1, and decimal place can have store values between minus 99 to 99, because I can have only two values on the left side of the decimal, right? So it can be 999 and 99 plus minus. What does this negative say? It is allowed to declare a numeric column with a negative scale, then the value will be rounded to the left of the decimal point. Okay, makes sense, makes sense, makes sense. So it will, I remember. So minus is like it will round on the digit on the left side of the decimal. So if it's three digits, it's gonna be like I can have two total number of. If it's a three, round the value to the nearest hundred and can store the value between. But is 2 and is negative 3, how then it will be 0, 0, 0, right? Is that possible? It also allowed to declare a scale larger than the declared precision. But how that's possible, right? I can ah okay, got it. So when it's negative, I will have three zeros and then it will have two values. It means that way, inclusive. So we'll round the values to the nearest thousand and can store the values between this and this. But if I do that, let me try to convert a value. I want to check this one. This is really interesting, right? So suppose I have four, 1, 2, 3, 4, 5, 6 that I want to typecast to numeric this one, and I want to check the value for this one. So what it says, field with precision 2 and scale 3 must be down to an absolute 10 to the power 5. I did it like .00, and a field with a precision 2 and scale 3 must be round to an absolute value less than 10 to the power 3. 4, 5, plus 6. Okay, it should be less than because 2 and 3, 5. And it round 3, right? So 1, 2, 3, and 12 is capital. What will happen when I have only one? 0. Okay, 2 is 0. 3 gonna be 0. And the 4, 1000. And the 5, 1200 because of this 3's. But now I exceed this one. Because negative says you can have, it will round the 3 digits, right? And after rounding this 3, it can have only 2 more. So 1, 2, 3, but it have now 3 digits. So it should throw an error. It indeed throw an error. And if I do this one, it does. So it can have 99. I got it. This is tough. First, okay, so it's just rounding up to the nearest 1000, right? Ugh, 800. So when I want to do a nearest 1000 or something, like suppose I want to do a nearest tens of anything I'm getting 1. So what is gonna be nearest 10 is 0. If I got a value 9, I can allow only 2 digit. Okay, it become 10. But if I do 11, it become 10. So if I go till 99, it become 100. uh, it is rounding off, right? It becomes 0 here. It's like sorry, 50, 20. So it's like 10th place, right? It is taking you to your 10th place. Okay, so it will take here. Oh, now I got it. Suppose it's, let me make it 24. I will tell you. It's 24, 23, right? So what it does, you need to round till the first digit. Okay, it will go here 3. 3 is your less than 5, so it will take you directly to 0 and it won't update this value. So it will become 20. But if it's 6, so what it does, it will make a 0 and it will just round to the next figure to that one. So it will become 30. 30, right? Okay. Now the thing is, I'm allowed to have one character after this. Okay. So what it does, you can have 1 0 and then one value after that. So 0 and 1. That means it cannot have more than this one. So if my value is 95, right, it's 95. It's gonna become 0 and it will upgrade that 9 to 0. So it will become 9 to 10 and it will throw an error because the maximum value I can have here is 10 ki power 2 because one for this one and one this one. If I make it like 2, it will be fine. 100, get 2. That means I'm allowed to have till 10 ki power 2 because of the negative. If I make it 2 and I go to 999, 999. So what happened? It will make it 0. Okay, and it will round to 9 to 10 and again it will make it 9 to 10. So it should be 1000, but it won't allow. Again, it's an field issue. Like if I make it 10 ki power 3, it is allowed. Okay. So it's a bit confusing, but that it is not that confusing. What it does is just rounding off with the negative on the left side. And if it's a negative, how many digit can hold is the addition of this two. 3 plus 1, 4. So it can have maximum 4 digits, right? And if it's like select 99 numeric, and I want to have two digits on the left, total number of digits should be 2, and I'm putting 1 on the decimal. I'm trying to this one. It should throw an error. What is it? Out here. You need to add this together. Okay. So two digit on allowed and one digit on the right side. The one. Okay, so total number of digits allowed is 3. So 3 minus 1. So that means 2 on the right side and 1 on the left side. So it will be 9, 9, 2. 9 and 2, yeah. It is indeed. Ah, so total visits are like this are equals to precision minus scale. So when it is negative here, so it's like total visits equals to 3 minus of precision 1. So how many digits should you have at given point of time? That will be 3 plus 1, that is 4 digits allowed. Okay, total digits equals to, again, precision is how many? 3 minus scale 1, that means 2. So total digit, uh, total digits, no, total significant digits. Significant is on the left side. Significant. Significant is to the left side of the decimal. So total significant digit is 3 minus 1, 2. So 2 is allowed. 2 is there. Yeah. This is interesting, dude. Dude, this is literally interesting. Marek is done. What is infinity on this one? That's I want to know. Numeric values are physically stored without any extra leading or trailing zero. Thus, the declared precision and scale of a column are maximum, not fixed allocation. In this sense, the numeric data type is more akin to varchar or tochar. The actual storage requirement is 2 byte for each group of 4 decimal digits plus 3 to 8 digit overhead. In addition, ordinary numeric values, the numeric type has a several special value infinity, minus infinity, and none. These are adopted from this standard and represent infinity, negative infinity, and not a number. This is respectively. When writing these values as a constant in a SQL command, you must put quotes around them For example, update table set x equals to quotes. Remember, the quotes is the single quotes in your uh, relational database management system. So it's single quotes. On input, these strings are recognized in a case sensitive manner. So you have to be very clear with the case sensitivity. The infinity value can be alternatively be spelled as inf and minus inf. The infinity value behave as per mathematical expression. For example, infinity plus any infinity value equals to infinity, as does infinity plus infinity. But infinity minus infinity yield not. Ah, infinity plus any finite value equals infinity. Infinity plus infinity, so does infinity plus infinity, but infinity minus infinity yield not a number because it has no well-defined interpretation. Note that any infinity can be stored in an unconstrained numeric columns because it notably exceed any infinite precision limit. Not a number value is used to represent undefined calculation result. In general, any operation with not a number input yield another not a number. The only expression is when operation other input are such that the same output would be obtained. If not a number were to be replaced by any finite or infinite number, then that output value is not a number. Two. Look, not a number is a bit confusing. The type decimal are equivalent, both are the part of SQL. Select numeric as num, and this is so numeric infi minus infi and nan. So sometimes it's really useful when you simply use these things. AI. So not a number, infinity and minus infinity. Not a number represent an unidentified or invalid result for. Okay, but can't I store no in calculation? So select any number. It's not a number. Possibility. Eh? Nan is considered greater than everything. Nan is equals to Nan, unlike other languages where Nan and Postgre is comparison behavior is different from most program ones. So these are weird behavior. How to detect and handle them? So like it's price is not the number. That's crazy. Listen, so if it's null, if then nan, and if it's nan, then it's zero. Importing bad or corrupt data, overflowing from external system, overflowing from external system. Why can't I use null instead of NK? Not on number. Understand like why I am using NaN instead of null. Null means value does not exist, the data missing unknown or not applicable. So null means none, none, and null equals to you can't even compare unknown. That's true. Nan means value exists but is mathematically invalid. Ah, the data is there, but the result makes no mathematical sense. So, Nan invalid plus anything. Not means value exists but is mathematically invalid. The data is there, but the result is no met. So, situation customer has no phone number. No, Nan, not a number. Is not collected in null. Square root of negative, not a number. Perfect. Okay, so null I'm going to use inside the column value of numeric when the value is missing or unknown. Man, I'm going to use for an operation or something where the output doesn't make sense to me, like something divided by zero. So instead of throwing an error, I will replace this with that. Right, makes sense. Or is null. It's true. Always false because null here where and up where clause strictly work on the true statement. If it is true, then only it bypass you or allow you to bypass. If not, it will drop. So if price equals to null is always written null or unknown, that's a false statement that will make the record filter out. So if you want to get if the value is empty or unknown, you need to use the keyword is null. But nan taking it as a value. So the value is there, but I am replacing it with none. That means this value is something you cannot use it numerically in a function. It exists as a value. It does get it, but this value doesn't make sense. Like dividing by zero. So instead of throwing error, you will replace it with null. So now average of this one. Null or skip fair average. If one is none, the result is none. Right. Because the sum of none is none. Multiplication of none is none, not applicable. That means not a number is not applicable. So null is like I don't have a value. I have a value, but it is mathematically broken. But practical null is always like what you want. Nan is like usually means bad data come in. And dude, this is really good. This is really good. This is something new I learned. Okay, so monetary type. I think I learned this one. This is not a big deal. Float for float 8 learned. Okay, character type. This is interesting. This is really, really interesting. Okay, monetary type. So numeric is done. Numeric was the money type is stored. So you store it as a numeric value. Trust me. Oh, the money type store a currency amount with a fixed fractional precision. Fractional precision is determined by the database IC monetary setting the range. I think I need to stop it today because it's already too much for today. And I need to complete few of the things. So I think tomorrow I need to continue for monetary, characteristic, binary, date and time, boolean, this one. I think for rest of them I won't touch, but in future when we will do project, I will touch them. Tomorrow I'm going to focus on monetary type, character, binary data. No, I will skip it. It is not needed. Then date time, boolean, and enumerate. If I have a time, then I will look at the geography, but usually I won't. I will skip. I think this is the one my intention is where I'm skipping this binary because numeric is done. Serial type is also done. Create serial. Yeah, we done it as part of earlier. And serial is three again: serial, small serial, and big serial. It work on the concept of the sequence, so it's like create sequence. This one by default it create at the back end and use the cur and next one. So it's not a big deal. Let's keep it aside. So tomorrow is going to be really, really interesting. We will delve more into the monetary character, date, time, stamp. That's interesting. Even interval is there. then time zone, Boolean, enumerate, and geographic type. I think I can look into it. I don't think it's needed. I think I will skip it for the time being. In the future, if I need it, then I will think of, but no. So this is the one my plan is. Numeric is done, I will recap. Binary data type, no, I'm not going to touch this one. This doesn't make any sense to do it at the first place. It's not useful. I haven't seen its use, but in future, when we create project and then we find it like, why not we use it and we will use it. But at the moment, it's going to be numeric recap, monetary character, date and time, Boolean, and enumerate type. Tomorrow, we're going to finish the data type, and tomorrow, we will finally be able to complete the week one, despite the fact that we took more time than the intended, our initial intent was. But it is what it is. Sometimes you go beyond. So let's quickly go to our GitHub repository. I have to uh curate few of the last 2 days of work as well. That's why I don't want to stretch it more. Roadmap. I hope it works. Now it's working. Okay, perfect. So select is done basically. Even I learned the rule. Insert delete is done. Tomorrow we're gonna complete this one, despite the fact that we learned a lot of today. So we will finish it tomorrow. So tomorrow the week one will be done, and we took like 4 day extra. That's fine because it will lay a better foundation. Now you see about where clause you are much more clear. I'm much more clear. Then yep, week two gonna be very enjoyable. Week three is gonna be fine. Week four, week five, week six, week seven, week eight. It's gonna be really really fun. Yep. With this, I will end the today's live session. I hope you enjoyed it. I enjoyed it. I learned a lot. I hope to see you tomorrow. Same time, 12:10 Irish